All right, moving on to section 8, we'll be looking at rational expressions. We have a rational expression right here in our cover, but let's go ahead and get into it. A rational expression can be described as a fraction with two polynomials, one in the numerator and one in the denominator. And let me just show you what that looks like. An example would be x over x plus 2, or it could look a bit more complicated. We could have this rational function, a rational expression. Right, so both of those are rational expressions, and it's always easier to deal with the simplified rational expression. So we're going to learn how to simplify these rational expressions, right? We're going to learn how to factor out when possible and cancel terms where it is possible. So again, let's look at examples here. Say we're given a rational expression of 3x squared minus 10x plus 3 in the numerator and 6x squared minus 8x plus 2 in the denominator. So to simplify this, we're going to, as we see up above, factor both the numerator and the denominator. We learned factoring last lesson, right? How to factor quadratics. So it's going to be the same thing here. I'm going to go ahead and factor those out. And from there, we can notice that both in the numerator and in the denominator, we have 3x minus 1. So we can go ahead and cancel those out. And we're left, cancel terms, and we're left with x minus 3 in the numerator, and in the denominator, we have 2x minus 1. Now, this is pretty much just factoring and canceling things out. But we're going to also be multiplying rational expressions. So let's go ahead and move on to that one. So multiplying rational expressions. Here we're going to have some steps. First step will always be to factor out each polynomial before multiplying. So that makes our lives easier. And I'm going to show you what that's going to look like. But the next thing to do is to multiply the numerator by the denominator, numerator by numerator and denominator by denominator. Meaning, just like fractions, we multiply straight across, right? And then from there, we're just going to reduce them to lowest terms. So let's go ahead and take a look at that. So we're going to have a question. Maybe they tell us to multiply some rational functions. If you want to try it yourself, go ahead and pause here and go ahead and try it yourself. But let's see what that's going to look like. So in this case, we're going to factor out first, just as our first step is telling us what our first step is telling us to do. In this case, we don't have to have a common denominator because we're not adding or subtracting fractions. We're multiplying them. So we multiply straight across. So we just bunch them together. That's going to look like this. And now we have both x plus 2 in the numerator and denominator, as well as x minus 3. So we're going to be able to cancel out some factors here. First the x plus 2 and then the x minus 3. And that leaves us with our simplified rational expression of 1 over x plus 3 times x minus 2. So pretty much like when multiplying and dividing fractions, adding, subtracting, rational functions, dealing with them is pretty much the exact same thing. Just maybe a few more steps because we have to factor, or, they look a bit intimidating, but that's about it. Nothing much changes. So now we're going to look at dividing rational expressions. I'm just going to go ahead and put all three steps up here. So it's pretty much the same thing. It's best to look at an example. So now we're being asked to divide the following rational expressions. So if you want, you can go ahead and pause here again. Try this out yourself. If not, let's go straight into it. First things first, we're going to factor, just as we did last lesson. Factor these out. Now, if you remember dividing fractions back in school, What we used to do is to multiply by the reciprocal instead. So this is going to look the same, but instead, if you notice, the only difference is these two, we flipped it, right? We flipped this, and then the division turned into a multiplication. That makes our life a lot easier because we can, when multiplying, we multiply straight across, and we can bunch them up together again. From here, we move on to our third step, where we just reduce them to lowest terms so we can cancel things out. I see an x minus 6 both in the numerator and in the denominator, so we're going to cancel those out. I also see both x plus 1s, so we're going to cancel those out. And there's a third one. We see an x minus 3, so we can cancel those out as well. We're just left with x plus 3 in the numerator, and in the denominator, we are left with 2x plus 1. So this is dividing rational expressions. And like I've said before, and I'll keep saying, with practice we'll get better. They become second nature, and they no longer look so intimidating. All right, well, the last thing we're going to do is adding or subtracting rational expressions. Now here, you do have to remember, when adding or subtracting fractions, we do need the same common denominator. All right, that's the big thing about addition or subtraction. Multiplying or dividing, it's a lot easier to just go ahead and do those more straightforward than adding or subtracting fractions. So this example here, it's a big example. Say they were asking us to add the following rational expression. So here I went ahead and did the first step. I went ahead and factored x squared minus 1. If you remember from the last slide, this is a difference of squares. So that factored to x minus 1, x plus 1. Now here, x minus 1, x plus 1 is a denominator, and over here we only have x minus 1 as a denominator for that fraction. So what we're going to have to do is multiply x plus 1 here to the denominator so we can have it match the other denominator. But if we're going to multiply the denominator by x plus 1, we're also going to have to multiply the numerator by x plus 1. I don't even know why I'm writing this down. I already have it written down. We have the least common denominator as x minus 1, x plus 1. So here it's a lot nicer. You don't have to look at my ugly handwriting. And now we have a same common denominator. Now that we have the same common denominator, we can add the fractions. Right, so the denominator stays the same as x minus 1, x plus 1, but now the top gets bunched up together. And here we can simplify. X plus 4x just becomes 5x, and then negative 2 plus 4 just becomes positive 2. So we'll simplify that to look like this. Now, can we simplify this further? Sure. We can just, instead of factoring the top, it might be a bit complicated. Instead, what we're going to do is just bunch up the bottom again as a difference of squares and just leave it as x squared minus 1. And we can leave our rational fraction like this. So that would be the sum of the rational expressions. Okay, that's it for rational expressions. Like I just said, last slide, practice, 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 and we're here if you need to ask anything.